Hey everybody, we're going to be doing 2.5 today. Um, this is again a lot of the same that we did before. We're going to be looking specifically at quadratics today. Quadratics behave slightly differently. Not really, but the nice thing about quadratics is we never really need to have a b. Um, B's complicate things, as you may have noticed from some of your assignments. And the nice thing about quadratics is that we really don't need it. So we can always get rid of the b if nothing else. Um, and so we really only have that a, h, and k. Okay, before we get into that, this is a skill we're going to need for actually next time more than today, but it's an important skill. So let's go over there and review it. Before we get into that, um, there are lots of ways to do things in math. I have found over time that I like it when students find a way that works for them. Please make sure that you are using your way appropriately and that you're not just using PhotoMath or some other program to do it for you. I want to be really clear. Like I really do want you to be able to use your own strategies. Please do. If you watch another YouTube video, you find someone that you like better and it works for you, please use that. But again, please make sure that you are understanding it and able to reproduce it. That's the important part. So today, again, when I was taught this back in a long time ago, like 2001, before most of you were born. Yeah. Anyway, when I was taught this, I was taught to do FOIL. First inside, outside, last. Or the rainbow, as you may have heard it. The bad thing about the rainbow is for two terms, it's not too bad. I got two terms, I end up with four terms. 2 times 2 is 4. When I have 5 terms and 6 terms, then I have 30 terms I have to deal with. Don't worry, I'm not going to have you do any of those today, or probably ever. But if I have 30 terms, I'm honestly pretty likely to forget one or two of them. And if I forget one or two of them, then it's wrong. So I want to be careful with making sure that I'm not forgetting terms. The box method, which was developed more recently, eliminates that. So for example, here I would have a 2 by 2 box. I'm going to put one of these terms on top, one of the terms on the side. Doesn't matter which. Just make sure you keep the parts together. Okay, and then I'm going to multiply. The nice thing about the box is when you're doing the box, the only way you're going to ever forget a term is if you have an empty box and you leave that box empty. But in your brain, you should be going, man, I have an empty box. I should probably put something there. And that's what you should do. Okay. So to put things in the box, we just take the two terms that kind of match up and go to it. So 2x, 3x is going to be 6x squared. 2x, negative 2 is going to be negative 4x. Negative 4, 3x, negative 12x. Negative 4, negative 2 is going to be 8. So then I end up with 6x squared minus 16x plus 8. Okay, again, I combined these two terms because they're like terms. But again, the key here is, and again, for like 4, you probably don't need to do the box. I would still do it though, because when we get to factoring, we're going to be going backwards on that, and it's going to make your life so much easier than factor by grouping. Factor by grouping is, again, one of the old ways of teaching it. It's long, it's tedious, and it's just not visually pleasing for students to learn. So let's do one more of these. Let's do number 4. And the reason I'm going to do number 4 is because it's a different size box. And to be honest, this one's probably easier just by distributing, to be completely fair. But just to show you how to set up a different box. So I got a 1 by 2 box here. So 3a, 4a, and then 1. So 12a squared, and then 3a. No like terms to combine, so there's my answer. 12a squared plus 3a. Okay. Again, if you need some extra help, make sure you're coming in for those RTF Fridays or during my office hours. For these ones, this is just a quick review from last time. I'm going to do one of these. If you understand it, great. Feel free to continue the video. If not, please make sure you're going back and watching the video again. It's better to keep these videos shorter for you so that we can keep them, so you're more likely to watch the whole thing. So I'm going to keep these short. I'm just going to do one of these. And if you're struggling, make sure you're going that. Okay, so same idea from last time. F of x, 5x minus 2, inside of absolute values minus 3. Now here I don't have an a, 1, but not important. I have a b, I have an h, I have a k. Okay, I already have a containing force here. So I don't need to add any parentheses. Remember, those parentheses only really need to go if there's nothing there that's an operation. There's no squared, there's no absolute value, there's no square root, there's no nothing there for me. There's nothing there for me to contain things. I have a containment here with those absolute values. Translation down by 1 unit is going to be a k, so g of x, 5x minus 2 minus 3, and then down, since it's k, it's going to do what we want, so minus 1. I can combine these like terms, so I end up with 5x minus 2 minus 4. Okay, now I need to be careful here, because in the last video I combined these, I got rid of the parentheses and combined these. I can't do that here. Absolute value is a new operation. Because I have that operation there, I can't just get rid of the absolute value. Absolute value has to do something first. On the one I showed you before, that was a linear, and linears behave very nicely. They don't do anything funky, so that's why we were able to get rid of the parentheses before. Okay, so again, today the nice thing is with the quadratics is we don't really have to worry about b. And if we ever have a b, we can turn it into an a. So I still have a, I still have h, and I still have k. The reason we don't need a b anymore is if I have a b on a quadratic. So I've got a quadratic. B did one of two things. It either stretched or shrunk horizontally. Well, let's think about vertically for a second. If I stretch a parabola, if I take this and I stretch it up, it's going to bring it narrower. And if I shrink it, squish it down, it's going to make it wider. Now let's think about this in the horizontal direction. So again, we said if we stretched it, it was going to make it narrower. Well, if I take this and I squish it in horizontally, what's that going to do? It's going to do the exact same thing. And then if I stretch it out, it's going to make it wider, or like squishing it vertically. So we have something that describes the same thing. Now, there are functions where this doesn't work, but with quadratics, it does. So we don't really need that b, which is really nice. The other thing b can do, remember, is flip over y. So it can flip this way, right? But if I got a quadratic like this, and I flip it over y, and I move this to the right, and I move this to the left, nothing changed, as long as it's centered. Now, obviously, if I had already moved my quadratic and done it in the wrong order and then flipped it, that's different. But as long as I do everything in the right order and nice and neat, if I flip this, it's not going to do anything. It's going to be the exact same function. So the nice thing here is, again, we don't really need that b because the b can either be turned into an a, and any negative b's don't really do anything. So I don't need that part of the function. I do just still need an a because a definitely does change it. And we need to show that stretch or shrink or that getting narrower or wider somehow, and a flip over x. And then the h and k. H and k is another nice little thing. So the h and k, what can turn into, and we call this form vertex form. And the reason we call it vertex form is because the h and k give us the vertex. Now the nice thing here is we're kind of done. A lot of these problems are going to ask you, hey, what's the vertex? So you just need to look in the equation and find h and k, and yay. Now you do need to be careful though. One thing, remember h is on the inside. So it's going to be the opposite of what makes sense, or the opposite sign. So for example, if I had x minus 2, quantity squared, plus 5. Okay, k just comes straight out. So this is just 5. But again, for this h, I need to flip the sign. So instead of positive, or instead of negative 2, I'm going to have positive 2. Okay, and vice versa. If I have a negative, I'm going to make it positive, positive, I'm going to make it a negative. Okay, so looking at a couple of these, I'm not going to do all of these. Let's look at a couple. So a couple things we notice. Some of these graphs are face down, some of them are face up. In fact, 3 of them are face down, 3 of them are face up. If I look up here, remember flips happen when we had a negative A. Well, if I notice, I have a negative here, a negative here, and a negative here. I have 3 negatives. So those must match up with A, D, and E, whereas the other 3 must match up with the other 3. Okay, so let's do A first. So on A here, again, I know it needs to either be big A, big D, or big E. Well, my H is going to be, it's a negative 2 there, so I need to flip the sign, so it's going to be positive 2. I don't have a K though. But again, thinking back to the last lesson, I can add 0 to something and not change it. So let's do that. Now I have a K. So if there's nothing there, you want to use 0 for that number. And obviously, if it's for H, you don't need to change the sign because 0 doesn't really have a sign. Okay, so I want to find one that's at 2, 0 and is face down. Okay, no, because 2, 0 would be here. This one's at 2, 0, but it's faced the wrong way, up. And then here, though, 2, 0 is my vertex, and it's faced the right way. So A is going to match up with D. Okay, doing B. Again, I'm not going to do all of these. I'm just going to do like 2 of them. Same idea. I'm going to take this. I'm going to flip the sign. So 2, 2. This one is faced up. So no. 2, 2 is going to be right here. So no. Yes, maybe. Let's just double check. Well, this one's face down, so no. And then no. Okay, so little b is going to come over here. Okay, again, this slide is just in the book. This is just showing you again that shift left right is opposite what makes sense, and then vertical translations up and down does make sense. So really quick, let's describe the transformations here. So my vertex, remember, +4 is going to really be a minus or a left 4, and then down 1. Okay, so starting with my graph. There we go. Okay, there's a quadratic. Now, when you move these, you always want to move it off of the vertex. Don't try to move it off of any of the other points. Always move it on the vertex. It's going to make your life easier. So 1, 2, 3, 4, and then down 1. So my new vertex is right here. It's going to follow the same pattern. And that's all we have to do on this. Let's do one more. Let's do one that has both shifts. Let's do number 2. So there's my original. I'm going to go right by 2. I'm going right because it's the opposite of what makes sense. We want to go net left because of negative, but it's inside, so it's the opposite. And we're going to go down 2. Okay, and then my describing is right 2, down 2. Okay, so this slide again is just showing that an A flips down, a B would flip over, but again, same spot, so it doesn't really matter. The vertical stretches do the same thing as the horizontal stretches, it's just kind of backwards. So again, we don't need the horizontal stretches. These are the 2 we really need to do. Okay, last problem for today. I need to be careful with this one. I'm going to rewrite it so that you have some parentheses. I don't have any parentheses here. Is that an A? Is it a B? What is it? So negative 1/2. I'm going to put those parentheses right around the X, even inside of the squared. Okay, and again, if I already had parentheses like I did on the other one, I don't need to add them. I don't need to add them here because I already have some. I don't have any here, so I need to add them because it's going to make a difference. This is not the same as this. And the reason is here, we look inside the parentheses, there's nothing to do. So this exponent happens first, following PEMDAS. We look inside the parentheses on the second side, there's stuff to do. This happens last here, this happens first here. So I've got to be careful, I've got to make sure that I'm putting those parentheses as close to the x as possible. Okay, so looking here, looking back at our rules from 2.1, what I want to do is first draw my original graph. Now, I have found over the past couple of days that I am finding that students who do the shrinks or stretches first are doing a little bit better. So let's do that first, okay? Again, we're gonna ignore this negative here for a second, and we're gonna just go look at the 1/2. 1/2 tells me it shrinks or gets compressed vertically. So something like, please play nicely. There we go. There we go. And then like this. And then that negative tells me I'm going to flip down. So it looks like this. Okay. And that's it for today. Again, it's a lot of the same. It's just now we're looking specifically at quadratics. Real quick, number 20. So on the last question on your assignment, depending on if you're online or in class. The last question on your assignment is challenging. It's what I like to call a weeder question. It weeds out the B's from the A's. It's in the academia world, we look at B's as good. You know, the person learned everything that they were supposed to learn. And A, though, is that above and beyond grade. You're going to need to think back to secondary 2 to be able to complete that problem. You're going to need to be able to create an equation from some points. Feel free to reach out to me for help, or use the online tutor or help section on your Big Ideas math. It is a challenging problem. It is meant to be a challenging problem, to help expand your minds a little bit and help you grow as a mathematician. Again, feel free to reach out to me if you have any questions, and I'll see you next time in the next video.